Hello viewers, my name is Mark Rosengarten, and as you can see by my zany hairstyle and immaculately white lab coat, I am a scientist. Allow me to introduce you to my lovely assistants. Today, our goal is to acquaint you, the viewer, with the wild and wacky world of
acids and bases and you!
Now the obvious question would be, what is an acid and what is a base? Well, there are three main definitions. The first is an Arrhenius acid or base. In an Arrhenius acid, a compound dissociates in aqueous solution to form a positive H+ ion and a negative ion. In an Arrhenius base, a compound dissociates in aqueous solution to form a negative OH ion and a positive ion. The second definition is a Bronsted-Lowry acid or base. A Bronsted-Lowry acid is defined as a compound that donates hydrogen plus ions. A Bronsted-Lowry base is one that accepts hydrogen plus ions. The third and final definition is a Lewis acid or base. A Lewis acid is one that accepts electron pairs. A Lewis base is one that donates electron pairs. I will now turn things over to my assistants, who will explain to you this lovely pH scale we've constructed of items you can find around your own home.
This battery has a pH of 0. This lemon has a pH of 2. This tomato has a pH of 4. And this water has a pH of 7, which is neutral.
This toothpaste has a pH of 9. This soap has a pH of 11. And this bleach has a pH of 14.
We will now take a short commercial break.
Hi, I'm an acid.
And I'm a base.
I release hydrogen in water, H+.
And I release hydroxide in aqueous solution, OH-.
I'm sour.
I'm bitter. I also feel slippery.
I don't feel like anything at all, but I do conduct electricity.
Well, so do I.
I'm useful.
But not as useful as me. I create soaps by hydrolyzing fats.
You are a fatty.
Excuse me?
Nothing. I am corrosive in metals.
That's not the only thing she's corrosive to. Besides, there's no point in even arguing this. I have the higher pH, and thus I am clearly superior.
Yeah, but you have a lower IQ.
Hey, then there's fighting words.
Fatty.
Oh, it's on like Drano in a drain! You gotta hit me, then don't back away. Ah!
We've resolved our problems, and now we're neutral.
Welcome back to the show!
Yes, the show. When handling acids and bases, it's important to keep a few precautions in mind. Please bring on the acid. Now, if an acid touches you, and it's concentrated enough, like this 10 molarity HCl, it'll burn your skin, then your flesh, then your bone. So don't let it touch you. Now, please hand it to me. Ah!
Oh my god!
That was acids. Now for bases. If I may please have a base. Not that kind, dear. Not that kind either. That's a bass. That's not even close. If I may have a base, please. Ah, yes. Thank you. This is 10 molarity sodium hydroxide, a very powerful base. Now, unlike acids, bases are entirely non-reactive with living tissue. Watch. If you were to pour a base on your skin, nothing would happen. Ah, no! Evidently I, Mark Rosengarten, was incorrect. I will now turn things over to my assistants who will explain to you about eye safety.
When handling acids and bases, it's very important to have goggles.
Not just have them, but wear them.
In case an acid or base gets in your eye, make sure to wash your eyes out thoroughly.
Ah!
Oh my gosh!
Well, I've certainly learned my lessons. I hope you have too. Thanks for watching our informational, educational presentation. Bye!
Bye!
I didn't do anything. No, Keisha, do you want me to not say Keisha? When handling acids and bases, it's important to keep certain precautions in mind. If I may have an acid, please. Now, not yet!